My screen is ridiculous. So there was literally, I found this PowerPoint online, but I couldn't download the PowerPoint. It's literally 31 slides of like how to do it from bond line to Fisher projection. So my desktop is an absolute mess. So you can, the screen sharing is disabled. You just gotta enable it.
Oh shoot. Okay. Let me
Go to
see.
security. I'm pretty sure.
Screen share.
Hey.
Hi.
Play. Is it enable the remote control of all applications?
No. It should just say screen share. Let me see if you go to, because I'm not host, so I can't see.
Right. Let me see.
If you can make me host real quick, I could probably just do that. That might be easier. If you go into participants and then make it host.
Okay. Let's see. There you go. Okay, cool.
Cool. Okay. Let me see. Yeah. Okay, yeah. So when you click on security, there's a heading that says allow participants to screen share, and
Got it.
I just enabled it. Okay. So I have I'm not going to go on the worksheet right now because I feel like this molecule is simple enough to that we should be able to do it. But I don't understand. I keep getting the opposite of everything. I'm like, and what I found like every time, like when I'm doing the RNS, RNS, the R and S, is that I'm getting the opposite. It's really frustrating. Do not share sound.
Let me make sure I'm pulling up my PowerPoint just in case we have any questions. It's right there.
Yeah. Okay. So right here.
What question was that?
This is just a separate question. I'm gonna pull up the homework too, but this one I feel like it's easy.
Which is the
I
second
don't
one?
know it, but either one.
Okay.
Really the first one
Okay.
is what my question is.
Which
Okay.
is
So
okay.
this is the first carbon, right?
Mm-hmm.
All right, so that's connected to a C right there.
Right.
So
That's a
this is going to be
carbon bond.
And so that's an ethanol. So that's, wait. Okay, that makes, okay. So that's going to be C and then H. And there's another H, but I don't feel like we're drawing it. So because this one is a C, it can go to either one of these first. So that's why I'm like, I'm pretty sure that's 2, right?
2 wedges?
No, to number the priority group.
Yeah.
Okay.
Yeah. So this is the thing. I'm just working through it. I don't know if I'm right. So,
right.
Because right here, so that's your C, and it's an ethyl. So that's the ethyl drawn out. So because ethyl's 2 carbons, 1 and 2 right there. So this C right here, so it's really CH, what is that? So it would have 1, 2, it'd have 2 H's. And then that's your CH3. Oops.
Mm-hmm.
Okay, so that's supposed to be CHH right there. And then those little lines are just the hydrogens for that first carbon off of there. So
Well, what was the answer that they gave on check?
I'm trying not to look at it.
Oh, okay.
It's because I just don't understand, like, what the fuck.
This was the worksheet number 6?
This isn't on a worksheet. This is just a random problem I found.
Okay.
that I thought would be, it's pretty similar to the things we've had.
All right.
So that's my problem, is that like,
Okay. Well, what using like
I'm listening.
previous knowledge? So he said that the more amount of substituents, the more stable it is. And then cis is least stable um, than trans things pulling out trans substituents. So like just from using that, now I could be wrong. A and D I would knock off because they're both cis. No, A and D.
Okay.
Does that make sense? I don't know because
So
I was just using those two alone.
wait. Okay. Oh, did you just help me go big brain? I think you just did. Okay. So when this is, okay, so let's say it's not like, let's pretend like this is 3D. It's not really going, it's going like this. And this is going like this.
Right. That one's
So
going
then
down. That
they're
one's going
the
up.
same side, and these are not. Wow, 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 wow.
Right.
Yeah.
So then now it's just these two.
Yeah.
And this is
So
where I'm stuck as far as, well, what makes the difference uh what
I
makes the
think
difference now?
I think it's the R and S stuff, to be honest.
Okay. And
Okay.
that's what's jumping me.
Yeah.
Like
So
I
I
can
know that.
only get so far and I'm like, well.
Yeah. Okay. So those are our chiral centers. Right.
Mm-hmm.
So the way I've been drawing my stuff, I've been doing one. Hold on 1 second. I'm sorry.
Okay. Whoa.
Okay. Um. So this is how I'm like drawing my little groups, so
Mm-hmm.
I can like figure out like what the hell is going on. Like, so my only problem is that I guess I should draw it like this. Okay.
Okay.
So oxygen 1, hydrogen 4. My thing is that for me, I'm thinking that you can go to this oxygen.
Mm-hmm.
Right? I just
Yeah.
everything I do is the opposite. Like every time I've checked my work, I'm getting it wrong.
Yeah.
It's really frustrating because
Let
this seems
me
simple enough.
I'm
So,
about to look up on the PowerPoint real quick just so I can see.
okay. So this would,
It should be past stereoisomers, huh?
Fisher projections. I would think so. Yeah.
Okay. Let's see. I see something about R and yeah, I see R versus S. Uh, hmm.
All right, I'm gonna look at the answer and see if we can maybe reverse engineer it.
Yeah.
Let's see. This is what I don't get. How do you know all of that? How are you? So that's S. Because ET is ethanol. Ethyl, sorry.
Right. Okay, wait. Let me look at the answer. What did he say? He didn't pick an answer,
Um, I guess it's A.
huh? Oh. Okay. Well, then that completely
Yeah.
is what I
I
was
don't,
saying.
because my thing is that, okay, where is this shit? So, yeah, look at all the tabs I have open trying to figure this out.
Cheese and rice.
It's so aggravating. So, like this one. Here's a good example from the homework.
Okay.
So, it almost, like, what?
Which of the following is a correct Fisher projection of the following compound?
Because
All right.
like, I
Well, then,
don't. Mm-hmm.
because now I'm a little frazzled because I can't even use the logic that I was using.
This one literally is so confusing to me.
Okay.
Because there's no, like, if you look at the wedges and dashes,
Mm-hmm.
you're like, okay, maybe 3 could be it. But I don't think that's the answer.
Wow.
Oops.
Okay.
And this Fisher projection stuff is wild.
What number was that? I'm gonna have
Um,
to email that one because I am shook all the
107.
way. 107 clockwise. Okay. I'm just looking at the PowerPoint. Yeah, I don't know, to be honest with you.
Yeah, it's like, what the hell? Like, was somebody just making this up?
Gotta be. Okay. Let me see.
So 1 is
So
right.
is S the reverse of R?
S is counterclockwise.
Yeah. Okay, counterclockwise, and so then R is clockwise.
Mm-hmm.
Okay. I couldn't tell you. Really, it's just really blowing my mind. Okay.
Yeah. All right, so let's
Let's
scrap
maybe.
that for now. Let's start
Yeah.
fresh. Yeah. All right. So let's go to. Okay. So.
Here's the Fisher projection. Shit. It's on 50. It's the last 5 slides.
Are you serious? Oh my
Yes.
gosh. Let's
Fisher
see.
projection. That's what he's talking about. with chirality centers, horizontal lines represent attachments coming out of the page. Vertical lines represent. Okay, horizontal lines represent attachments coming out of the page. Vertical lines represent attachments going to the back of the page.
See, I'm good right here. This I'm fine with. A-okay. When they're both wedges, because
Right.
they're on the horizontal, that's what's confusing me.
Okay. So that's forward. That's backward. And then, yeah, let me see that right there. Picture projections are most useful when drawing molecules having multiple chirality centers like sugar shown below. Okay. So those are coming all forward. The horizontals are coming all forward. Vertical ones are coming back.
And there's your
Okay.
dashes.
Okay. Got it. Got it.
Okay, so because this is a
Picture projections are also useful to quickly assess stereoisomeric relationships. I probably butchered that just now that I said it, but
these words are too long. Ridiculous.
okay.
So, like, let's
Okay.
see. So these would be that, and these would be diastereomers. Basically, if you get the mirror image, it's going to be the enantiomer. Sorry.
It's just flipped. Okay.
Yeah.
All right. Cool.
Yeah, because that's like that's like the definition of chirality, is that the flip happens, and then because that's the thing I wasn't understanding, is that this one gets flipped, and then it goes here, but then you put this whole thing back on it, and that's how you do it. So this would be BR, and then BR, and then H, and then H, and that's why they're in
For the
enantiomers.
not the nationwide, huh? The D one.
No, I'll show you in a second.
All right, cool.
But so I'm showing you the relationship between these two. I'm just breaking down exactly what it is, like
right.
The chirality, because like I said, so when you spin this one,
mm-hmm.
and it turns into this one,
right,
and then when you move it back over, so the BR is over here on this one, it's on top of it. They're still two separate things,
Oh, okay.
So that's when they're enantiomers.
Okay.
And then these are also, I'm pretty sure, diastereomers, because like the diastereomers, it's like you flip one bond only.
Mm-hmm.
So you see how like this one stays the same,
But then the
this
other one
got
crosses
flipped.
over. Right.
Yeah.
Okay. That makes sense. Right.
Okay. So. Okay. I didn't watch the video for the ENC. I haven't gotten that far. But
Okay.
only thing I know is that Z is cis and E is trans. That's all I know.
Z is cis, E is trans.
Because I think of like cis.
Mm.
That's how I remember. I have
Okay.
stupid shit for a lot of things.
It's okay. All right. So let me look back at that thing one more time.
This one?
The question that you had. The question that was on Chad. Okay. Okay, so would that be the one that they have showing, because the OH is on the other side, would that be a isomer?
Well, you're trying to draw this as one of these. You're not doing any stereochemistry yet.
Okay. Okay, cool.
So, okay, yeah, I'm going to table that one. Maybe we can try this one. Okay. So, I need a happier color. I don't want blue. Okay, so 2s. So we're gonna go counterclockwise. And then these two are gonna be, oh wow. They're gonna be clockwise. Okay, so for 2, we want it to be S. So I'm just gonna arbitrarily pick one. So oxygen is our 1. So this one is connected to a C and an oh, okay, I may have figured something out. Okay.
Uh-oh.
So this one, this carbon 2 is attached to carbon 3 right here.
Yeah.
No, I didn't figure anything out. Cool. Good to know.
Okay.
I thought I understood it. So, all right, because right here, this is gonna be. Can't see that shit. C O O, because double bonds count as 2 of the atoms.
Mm-hmm.
Let's see. I'll tentatively call this 2. So this is R this way. So I'm gonna abandon.
Clockwise.
Yes, I'm gonna
All right.
abandon this one on the left, and I'm gonna try this one right here. So this would be 1, 2, 3. Okay, so this one looks good for an S. So here's my thing: is that because wait, I'm just thinking of that stupid bullshit with the H when the H isn't on the dash, and you have to reverse it. How can you tell from these?
Okay.
Is this wild? Like, what the fuck is going on? So, 1, 2, 3. We'll tentatively call this S. And then, so, that'd be 1, CH. I don't fucking know. This takes too much work. Yeah, I'm just confusion.
So from what I'm gathering,
Mhm.
whenever you're numbering them, I know like the S is counterclockwise, the R is clockwise.
Yeah.
But like, how are you? I'm trying to say.
Determine the order.
Yeah, like how do you know where you're going?
So the way the priority groups work, it's based on atomic number.
Okay.
So like here, you have this carbon number 2 attached to carbon, hydrogen, carbon, and oxygen. Oxygen's atomic number is 8 and carbon's is 6. So oxygen's your highest priority. So it's going to be
Okay.
your number 1. And then hydrogen's basically always the 4th.
Okay.
I think
So
for,
all right.
Mhm.
All right, that makes sense. That's like highest priority. Okay.
Yeah, they call it priorities. And like, y'all's priorities aren't straight. Y'all were too bored coming up with this shit. So get my little chiral center. So here is a C. And the C is attached. Do I have to count? Oh, wait, no. 1, 2, 3. That's another carbon. That's why I want to say this one's 2. So, all right, here is 1. Okay, so these both have OHs. and then they both have C's.
Right.
And then, because I'm just going down the line, basically.
Would it,
Mhm.
because, okay, so that C is attached to the C that you have in the middle with the OH and the H attached to it. It has a C and a C. So wouldn't that be achiral because it has two of the same?
The thing is that this group
Mm-hmm.
is different from this group.
Right.
They're different.
Yeah. Both of, I can see the two N groups being chiral, but the middle one, that's what's.
Okay,
Oh,
so
wait. Never mind.
you
Because,
remember
okay.
you remember the
Yeah.
basic definition? It's like the chiral is for like different groups. And so and it goes down the line. So that's how you determine the priority.
Right. Okay.
Yeah. So this is one. I don't really know how to properly like break this down because here. Okay, so it's attached to carbon. Do I go here? Do I go here? You know?
Right.
Okay, so then let's just tentatively say
Is there
okay.
like a video? Hold up.
Where?
My last year, like they had like this website that does pretty good for explanations on this.
Let's see what this thing has to say about it. Okay, so it's the third one. Okay, so I was right. The first one was S. No, I was on R on the other one. See, and that's the problem is that I feel like it's because it really looks like it's S, but then because the hydrogen's messed up, you go in the opposite direction. That's what I have a feeling is what's happening a lot.
Mm.
See, this one looks simple.
Following pressure projection. Okay, so then it'd be because the horizontal comes up on the page, right?
The horizontal is your wedges.
Yeah, the horizontals are wedges. So then it would be these are on opposite sides. The H is right there, H is right there. Then it'd be, is it B?
You said B?
I'm thinking B.
Yeah, that's what I think too.
Okay.
A. There you go.
That's easy. Wait.
A.
So how is it A? Because did it flip? That's what I'm thinking now. Now that you say it flipped.
So there's this file that I found where it does talk about flipping things. Here we go. This is a different thing than we're used to seeing.
Wow.
But
Stays, flip, stays.
so let's see if we can apply that to another one.
Okay.
All right, let's try it on this one. Ah,
But there's only two. Oh, freak.
oh my gosh. Come back. There it is. Okay.
Okay.
So in this convention, the H is on the left.
Mm-hmm.
So here, we'll call that a dash. So the chlorine here would be wedged up next to the F.
Okay. Wait. You said okay. Which H you said was on the left? In the Fisher projection, right
And this
there.
one right here on the
Okay.
bottom.
Oh,
You
okay.
can see
Got it.
how the F is at the head.
Yeah.
Yeah. So by this pictures convention, as a theory, we're gonna give CL the dash.
Okay.
that's up there. So we're going to eliminate 1 and 2. All right, so then in the next bond, OH is on the same side, right here, and they
Mm-hmm.
both have dashes. Okay?
Right.
Because it's flipped. Who made this up? I just need to talk to their manager. So since this one's the same on the same side and they're different wedges and I mean they're the same wedges and dashes.
Yeah.
Let's just go through. Let's see. It's 2. Now, great.
Well, wait. Let's look at 3 and see first.
Let's see.
F. So it looks like it's dotted.
Yeah, that CL is dotted too.
Okay.
Because I would be between, because like just normal without looking at that picture, in the beginning, I'd be between 1 and 2.
Mm-hmm. Okay. I'm gonna say that I understand why it's 3 based off of the other one.
No, it's 2.
It's not 3.
No, it's 2.
Oh shit! I'm looking at
Yeah.
C. C. Shit. Okay. Well, let me just.
All
Okay.
right. So they're doing the R and S from here. Okay, so if we can do that, let's just do it ourselves. So, oh my gosh, that's terrible. All right, so chlorine is higher than fluorine is higher than carbon. So that's the fucking thing. Oh my gosh. Okay, big brain moment. Okay, remember? Okay, I need to make this right. It's bugging me. So, all right, we established 1, 2, 3. So ugly. 4. Oh my gosh. So bad. I cannot wait to get an iPad.
Yeah.
Dying.
Okay. Cool.
So remember that stuff on the horizontal is on wedges.
Mm-hmm.
So it appears S, but it's really the opposite because of this hydrogen. Yeah, you remember that?
Yeah.
Okay, so as I like to do, I like to do this in my notes. I have to do S and then R. Okay. Erase that. Okay, so we got that one. 2. Carbon. Let's see. Carbon. I'm gonna say 1, 2, 3. Ah, but then it doesn't make sense when you account for this wedge because it goes S and it goes R. What the actual fuck is going on? Like, if I am I the? I don't feel like I'm saying anything like wrong. Like doing all the conventions that we've learned. I just don't get it.
Okay.
Did you find the video?
Let me, because I was trying to make sure I wasn't missing anything you're doing.
Oh, well,
But
it's all just garbled.
let me see. So the topic we're talking about, organic chemistry. Let me do S and R. S and R naming.
Based on this sheet I'm looking at off of Chegg, it looks like wedges are S and dashes are R.
Wedges S, dashes R.
That's what this is showing me. I don't get the relationship though. I don't see how I can conclude that. I don't feel like when he was going through the worksheets, everything was like, oh yeah, I understand. Like, did you ever feel like that in class? Where you're like, of course I get it. Duh. And then you're on your own, you're like,
because he makes it sound easy. Every time I'm by myself, it's like, what am I even doing?
Yeah, like I've never looked at a chemical in my life.
Exactly. I have this video, but it's not like by the same people that video that I did see. I watched a video on Nationmers. All right, share my screen. I don't know if this is gonna be of substance. I'm gonna tell you right now.
Anything to get some understanding.
Okay, make sure my.
Oh, this is my boy. Oh, this dude's a legend.
Oh, okay.
He
Is
helped
he
me
gonna
through
talk?
chemistry.
Oh,
Yeah, he's talking. You have to share
can...
the sound when you But I watched this video last night. But
oh, frick.
no, it's fine. No, I need to watch it more.
Do we have the R isomer or the
There
S
it is.
isomer? So we need to find out. If the bromine atom is in the front, that means that the hydrogen is in the back. And now we need to rank the 4 different groups that are attached to this particular chiral carbon. A chiral carbon is a carbon that has 4 different groups. The bromine atom has the highest atomic number, so it's going to be ranked as group number 1. It has the highest priority. Now comparing the propyl group compared to the methyl group, the propyl group has more carbons, and so that's going to be group number 2. Number 3 is the methyl group, and hydrogen, which has the lowest atomic number, will be group number 4. So counting it in the direction from 1, 2 to 3, notice that the rotation is counterclockwise, which means that we have the S isomer when H is in the back.
Okay.
Yeah, I'm with you.
So this is going to be called S 2-bromopentane.
That's fine.
So let's work on another example. Go ahead and name this particular alcohol.
Oh, that's okay.
Let's begin by identifying the longest chain. So there's 6 carbons in a chain. So this is going to be associated with the name hexane. And we have an alcohol on carbon 2. So this is going to be hexanol, but specifically 2-hexanol. The suffix OL tells us that we have an alcohol functional group. The last thing we need to do is identify what type of chiral carbon do we have. We need to know what the configuration is. Is it R or is it S? Now, because the OH is in the back, the hydrogen has to be in the front. So let's go ahead and rank.
Method for flipping
Let's remove
the stuff. That's
the numbers.
He lost me on it. Like usually he teaches really well, but it's way too involved when he gets into it later. I don't get it.
So the oxygen has the highest priority since it has the highest atomic number. And the butyl group has more priority than the methyl group. So this is going to be number 2, number 3, and H is going to be number 4. But notice that H is in the front. And so you can go ahead and count it now, but you need to reverse it because you want to get the configuration where group number 4 is in the back.
I'm there.
So counting it from 1, 2 to 3, it appears to be going clockwise, but we need to reverse it because H is in the front. So it's really going counterclockwise, which is associated with the S configuration. So the answer is S2-hexanol.
So do you get why you reverse it?
Not really.
So you're just looking at it from another angle,
Try this
basically.
example.
Okay.
You're looking at, when you
So we need to
reverse it, you're
identify
looking
the
at the
longest
OH
chain.
from the front, so it
Now,
becomes the
should we count
wedge.
from the left side or from the right side? If we count starting from the left side to the right side, we have the iodo group on carbon 3 and the methyl group on carbon 4. But if we count it in the other direction, the iodo group will still be on carbon 3, but the methyl is now on 2. And 2, 3 is lower than 3, 4. So we want to count it from right to left, since it gives us the lower numbers. Now we have an iodo group on 3 and a methyl group on 2. Let's put it together. And we have to put it in alphabetical order whenever
Can you
we
still
have
hear?
multiple substituents. So this is going to be called 3
You can still hear?
iodo
Yeah.
dash
Okay,
2
cool.
methyl pentane, since we have 5 carbons in the longest chain. Now the next thing we need to do is identify the chiral centers. This carbon is not chiral because it has 2 similar groups.
Okay.
I'm gonna do
Goddamn ads. 2 ads.
Another one.
This carbon is chiral because it has 4 different groups. It has the iodine atom, hydrogen, the ethyl group, and the isopropyl group. So we know the iodine atom has the highest atomic number. Now which group is higher, ethyl or isopropyl? Well, let's look at the carbon atom that's attached to the chiral carbon. This carbon is secondary and this one is tertiary. A tertiary carbon has more priority than a secondary carbon. So this is going to be number 2, number 3, and H is number 4. Now, the hydrogen atom, group number 4, is already in the back, so we don't need to reverse it. So we can count it from 1 to 2 to 3. And so this is going in a counterclockwise direction, which is S again. So the answer is S, 3 iodo, 2 methyl, pentane. What about this example? Go ahead and try it. So notice that we have 2 chiral centers.
Mhm.
But let's name it first. So we need to count it from right to
Pentane?
left. We want the substituents to be on carbons 2 and 3 as opposed to carbons 3 and 4.
3 chloro, 2 fluoro, pentane.
Now we need to put it in alphabetical order. C comes before F. So to name
Right.
it, it's going to be
3 chloro,
3 dash chloro
2 fluoro,
dash 2 dash fluoro
pentane.
pentane, since there's 5 carbons in a parent chain. So now let's analyze the configurations of each chiral carbon. So relative to this carbon, fluorine has the highest atomic number. Now you might be wondering that chlorine has a higher atomic number than fluorine, but what you do is you compare the first atom attached to the chiral carbon. So you're comparing fluorine, hydrogen, carbon, and carbon. You're not looking at the chlorine atom yet. You look at the first atom attached to the chiral carbon.
Okay.
Fluorine has a higher atomic number than any carbon atom. So fluorine has the highest. Now which one has the second highest? So first we need to compare
The
these
one on
2
the left?
carbons. And if you go past that, if you look at the hydrogen and then the chlorine's going to win. But if you look at just those 2 carbons, the carbon on the left is secondary and the carbon on the right is primary, which tells us that this group has more priority. So that's going to be number 2. Carbon has more priority than hydrogen. Now, because the hydrogen is in the front, we're going to have to reverse it. So count it from 1 to 2 to 3. It's going in a counterclockwise direction, but we need to reverse it, which means it's clockwise. So therefore, we have the R isomer at this particular chiral center. Now, what about the next chiral center? So this time, the hydrogen is in the back, so we don't need to reverse it. Relative to this chiral center, chlorine has the highest atomic number. So this is group number 1. Now, this is definitely going to be group number 2. The ethyl is number 3, H is number 4. So counting it from 1 to 2 to 3, it's going in the counterclockwise direction. So therefore, we have the S configuration.
Mhm.
Now keep this in mind. The R configuration is on carbon 2. The S configuration is on carbon 3. So we're going to write 3S. As you can see, this is carbon 1. Carbon 2 is a chiral center with an R configuration. Carbon 3 is a chiral center with an S configuration. And here's 4 and 5. So to put it together, it's going to be 2R, 3S, dash 3-chloro-2-fluoropentane. And so that's how you can name a compound with 2 chiral centers.
Okay. So, all right,
So let's do the work. Want to do the worksheet?
all right. I'll stop sharing.
I'll open mine if I can find it. S- Okay. Okay. Start at the beginning.
Okay.
So, right here. So stereoisomers. Oh wait, can I? I think I'd rather do this. Okay. So this one, no, it's not working. All right, so this one right here, that's 1, 2, 3, 4, but these are methyls, so they're identical, so that's not a chiral center.
Mm-hmm.
So this one right here, 1, 2.
That one's chiral, right? Because it has that
Yeah.
ethyl
Yeah.
and then, yeah.
So 2 to the 1 equals 2.
Right.
All right. All of these you can eliminate.
Mm-hmm.
And then right here, that's 3 bonds. And then that'd be another H. But these all are the same. So like you go here and you go here, they're the same. You go here, you go here, they're the same. And then you wind up here and it's still the same. So 2 to 0.
That's 0. Cool.
Okay.
That one has a chiral in the right at the OH bond. If you were to cut it in half, because you'd have that one thing sticking out. Or maybe I went too fast. I don't think I went where you were going.
What I just arbitrarily picked that one. Okay, so let's start here. Okay,
Yeah.
so we have an H, right? So that's one group, 2 group. And then I guess this one right here counts as 1. And that would count as 1.
Mm-hmm.
Let's see. I'm just referencing my worksheet. Um, so for right here, this is your first different one,
All right.
your second different one,
Mm-hmm.
so my thing is that I don't see how these are different at this point.
The third and the fourth.
Yeah, like those right there.
Okay. From what I'm seeing, because of that metal that's sticking out, if you were to cut the bond in half, it wouldn't be symmetrical on both sides like we did the
Like this.
that one methylhexane. Yeah, if you split it down the middle, then you have that extra on the side. It's not symmetrical. So that's why the carbon point right there would be chiral.
Okay. Well, let's just try this one. Okay. So I would say this is 1. That would be 2. That would be 3. Would this count as 4?
Yeah.
So 2 squared 4.
Mm-hmm. That looks like to me. That's what I put.
All right. On to the next one. All right. So like this way, you're looking at it. Like basically this is just flipped. Like when you invert these, you get this is like the definition of an enantiomer right here.
Mm-hmm.
When you flip the bonds perfectly. So if this were a wedge, instead, it'd be a diastereomer.
Right. Like the second one that we're about to
Yeah,
see here.
exactly.
So the second, okay, so in the next, I get stopped up every time I try and say it. Can you say it, please?
An enantiomer.
An enantiomer. I've been saying enantiomer.
No, it's such
so
a weird
crazy.
word. It's just who sat there and like threw Scrabble tiles and was like, oh,
There it is.
bet.
So what you just said, that one is just flipped versus the
So
D one, it's flipped and then one comes like one switches. Like, you know what I'm saying? What I'm trying to tell you?
yeah. So like
Okay.
these are the same.
Yeah.
So we're thinking,
That one
okay,
flipped.
yeah, so this is and then diastereomer. All right. So right here, we can see that it's not. All right, we'll start at the OH, right?
Mm-hmm.
So, okay, those are flipped. That's looking good. Like, okay,
Correct.
maybe it's an enantiomer. So then we'll just go counterclockwise. So the H went from here to here.
Mm-hmm.
And
The
then
CH,
there's 3. Yeah,
the
exactly.
CH3 and the H flip, like they rotated.
Yeah. And then additionally, this is
I am so sorry for all this noise.
oh, I'm listening to
Jesus.
music and I'm listening to music in the background.
Oh, okay, cool.
Yeah, it doesn't bother me. So I also am led to believe that any geometry changes are also inclusive of diastereomers,
Okay.
meaning if it goes from trans to cis right here.
Yeah. And that in my head, I knew it couldn't be the same compound just by looking at that, but not using the terminology. You know what I'm saying?
Yeah.
Because the terminology is so hard to use
And it's
and
so
to sound like you're making sense. So
exact.
I put it in my own vocabulary. It's like, do you understand what I'm trying to tell you? Because I know it can be hard from where I'm trying to come from.
Yeah, it's like super dense. It's a
Yeah,
lot to take in. All right.
that was actually not bad.
All right, this is so small. Can I, whoops. Can you see my screen still?
Yeah, I see it.
Okay, cool. Um, almost lit my paper on fire. Okay. All right. So this one looks good to start with,
Okay.
right? Because your nitrile, I don't know what it's called, group, this ethyl,
Ethanol? Is it ethanol?
yeah. Yeah,
Because
I'd say
okay,
so.
because the OH.
So it's like burnt, burnt. And then is that carboxylic acid?
I have the little
I,
thing. Hold up. Let me.
I forgot. I forgot to be honest.
A double bond O connected to an OH is, yeah, it is a carboxylic acid.
Okay, lit. One thing I got right.
Look at you doing your smart thing.
Ugh, this is killing me softly already. I'm not sure if it's very soft either.
A hard death.
Right. So right here, this is gonna be our first one, obviously. And then this is our fourth.
Fourth.
All right, so this carbon is CHH. And then this carbon is COO.
H. H? No.
I'm
Where's
just
the
doing
CO?
this one right here.
Oh,
I'm
okay,
doing
cool.
this one right here because
Got
of
it.
double bonds.
Right.
And then, oh, I see what you're saying now. Sorry. Wait, no.
That wouldn't work. I don't know.
No. Okay,
Okay.
yeah.
Disregard what I'm saying.
It's okay. So carbon, carbon, oxygen, hydrogen. So this is our 2, and that is our 3. And hydrogen is on the dash. We're going clockwise. R.
Okay.
Okay.
So could the H, the dotted H that you have, could it have been on the left side?
Yeah,
Okay, cool.
it's
'Cause
just where I drew it.
right. Yeah.
I hate that you can't annotate and move your thing. That's so aggravating.
Yeah.
Okay.
I'm actually jealous because I don't have software like that.
Oh, this is just
Or you
Zoom.
can draw on it.
This
Oh,
is
really?
Zoom. Yeah, I'm using Zoom.
Excuse me, because I don't know what the frick is going on.
I use Zoom a lot, so it's okay.
Wow.
All right.
The more you know. I didn't even know you can do that. Wow. That's crazy.
Okay. That's our 1, right? So right here, this would be like, I'm gonna put it in backwards order, but we're gonna go, oops, we're going up. To go down the chain, we're gonna go up those. So
Got it.
carbon, carbon, oxygen versus hydrogen. And
Oxygen wins.
ka-cha. So you get
You're
2 and you get 3. And hydrogen is a wedge. So 1, 2, 3, 4 counterclockwise. Or
so okay, just to make sure what I'm understanding what's going on.
mhm.
So the priority goes by atomic number.
Atomic number, yes.
Okay. So the lowest atomic number or the highest atomic number?
Highest.
All right.
You're gonna sort your priority in descending order. So bromine is bigger than chlorine, is bigger than fluorine.
Bromine.
Bigger.
Okay.
You're just going down the period
Right.
of the
Bromine.
periodic table.
Okay. So with NH, that's the atomic number of both nitrogen and hydrogen, correct?
No, no.
No?
You only
Okay.
look at it one atom at a time. So that's why, oops, oh, my screen just went dark. Hold on. That's why, what is this doing? Oh my gosh, it's being silly. My computer is being a bitch. Sorry. Um, every time I turn my brightness up, it turns it back down automatically. Okay. You're looking at it one atom at a time. So let's start taking from the top. So we'll just start here. All right. So we already know hydrogen atomic number 1, automatically assign it to 4.
Mm-hmm.
Now here, we're going to look at N, C, and C, because those are the first ones in line.
Oh, great. Okay. Wait, yeah. N has 7, carbon has 6. I just took you on a big old loop for nothing.
No, it's okay. Yeah. So then to take it further, so here we break down that tie, and then that's when we look at these two.
Mm-hmm.
So let's just pretend that this was an oxygen for a second.
Right.
So this is really COOH. So this way would be check, 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 X. If that were the case.
Right. It'd still be the same thing that we're doing.
Mm-hmm.
1, 2, 3. Okay.
Yeah, but just
okay.
for comparison purposes. Okay. So this is Dr. Trudell's tests seem very fair.
Mm-hmm.
I think they're good. I'm just like
the what is it? The pretest. That was a pretty good representation.
Oh, the trial.
Yeah, the trial, and then both of the practice tests, both the multiple choice, like if we were in class taking it, and the written response practice test.
I only looked at the written, like I'm talking about the exams from other classes.
Yeah, from like I think this summer.
Yeah, the summer one. I remember looking at it and I was like, I hope that's us.
Right. Yeah, it was. That was pretty
spot on.
A pretty good example. Yeah.
All right, so 1, 2, 3, 4, 5, 6. So we're at hexane.
Mm-hmm.
Okay, so if we go 1, 2, 3, 4, 1, 2, 3. So I can't edit my words. That's fine. Okay, so we're at 3-chlorohexane. Cute.
Mm-hmm.
All right, so now, oh Lord. we're going to draw our H. And I'm just, because I'm used to this, so I've been doing it. I like to separate everything. That looks bad. I like to go 1, 2, 3. And then you can see like the tetrahedral like this too. It's kind of cool.
Right.
All right, so chlorine, well, we're gonna sort out Miss Hydrogen. Chlorine's gonna be 1.
Mm-hmm.
So here it's gonna be CH H. I'm doing this a long way. I'm sure we know the answer to it, but just to
I like when you do this like this, so it's actually drawn out, so you can get a better understanding of it.
yeah.
And then the 3 H's.
And then just for posterity, I know we're not going to get this far, but okay. So, check, 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 check.
Mm-hmm.
All right. So we're going to go carbon, carbon, hydrogen, hydrogen,
Mm-hmm.
hydrogen, hydrogen. We ran out. We go to the next one.
Right.
Carbon, hydrogen.
Exo. Oh God, I love this.
So we're going to go 2 and 3. And hydrogen is on the stack on the dash.
Mm-hmm.
So 1, 2, 3, 4. That's,
Clockwise.
yeah.
So R.
Yeah.
Okay. Look at this. Look at this. Mm-hmm.
Right.
Love to see it.
I hope the test is exactly like this. All right, I'm gonna clear
It
that.
should be. He's really not that bad. Now, what's his name? He
Jersey.
does. Nah, he does Jin Kim 1 and 2. Hawk. Oh God,
Yeah, I took.
awful.
I'm from Delgado, so I took my Gen Chem not at UNL.
Oh, well, you missed out on a good thing. You missed out in a good way because Hawk was awful. Yeah, Jin Kim 2, I struggled. Now 1 wasn't bad because I was fresh out of high school, so it was
Yeah.
all high school shit. But 2
Yeah.
was like elevated principles on the high school stuff.
Yeah, my
Awful.
problem with it is like just the math part just hits you like wild.
Oh yeah,
like,
that 2 was strictly math, PKAs and all kind of shit. I was like, oh God.
Let's see. 1, 2, 3, 4, 5 pentane. We're gonna start this way. So 1 bromo, 3 methyl. Are we good with that?
Yeah.
Okay. I don't have the answer sheet to verify myself, and I don't have it pulled up. I'm just gonna have to happen later. Okay.
Yeah,
So
I can pull it up on the side.
cool. Okay.
Or let's do this one first. I don't want to pull it up and looking at the answers. I mean, let's do it and then I'll pull it up.
Okay. We're gonna get our first group, our second group, our third group, and our fourth group. Okay. So we're gonna have C H H C H H C H H H. Okay. Miss Hydrogen. See you never. All right, so we're gonna start here. All right, fine. So carbon, that's not the right color. All right, so carbon, carbon, carbon. Hydrogen, hydrogen, hydrogen. Hydrogen, hydrogen, hydrogen. All right, so we have to move to the next one. So here, bromine, carbon, and hydrogen. So bromine's higher.
Right. So then that would be the next.
So
That's
that's
the next
going to
one.
be your 1.
Mm-hmm.
Carbon versus hydrogen, 2,
Mm-hmm.
3. And then this is on the wedge. I don't color my wedges in. Probably a bad habit. Okay, so we're looking like S.
Yeah. I had to like go like and then close my eyes and be like, okay.
Yeah, like,
How does the clock go? I'll be
I
like,
know.
okay, there it is.
I also want to I want to show you something and see if you can make sense of this, because I think it's a really good tool, but I can't figure out how to use it.
Okay.
So R1 bromo 3 methyl. I can actually do ME. That's actually legal. Wait, did I say 3? Stupid.
Yeah.
Retarded. All right. Yeah. I just looked at it. I was like, wait, that doesn't make sense. I was like, where'd that extra? That's pentane. Okay. So let's see if I can check. All right. I think that's good. That's probably good. Okay. Now, I think we're good on these. So let's see what we can do with the Fisher. All right. 1, 4. Yeah.
Got it.
All right. So check, check. So this loses out over this.
Right. So then that's 3. That's 4.
Right.
Mm-hmm. So then
And
it's clockwise. Wait. No. 1. Oh, wait. Never mind. How am I going to do that? So the H can rotate however you want it then, right?
well, what do you mean by that?
Like you can move it around since it's on. Like, okay, so I'm trying to make it work to where it goes after the 3 and then it'd be clockwise. But I don't know if I'm correct with what I'm
You
saying.
basically ignore the H.
Okay.
That's kind of what I've learned to do, is just ignore the H, because you're going to come back to it no matter what.
Right.
You're not going to change your order. But just realize that this is on a wedge and not a dash. So 1, 2. Oh, it's clockwise.
Yeah, I seen it, but then the 4 was right there, but now you say to ignore the 4.
I mean,
But
you can.
because the 4 was right there, I was like, well, maybe it isn't that because it's some kind of way it's supposed to be.
Yeah, these are only this is just the priority group numbering. The way I write it in my notes, I put circles around it so I know that it's not me numbering the parent chain or whatever.
Okay. Let's do one more and then let's probably put put it on the table for today.
Yeah, I think we. I just want to show you this one sheet after this. It's really quick.
Okay.
Right. So let's do this one. Yeah, because I don't know the other stuff at all. All right, so let's try to do less drawing to see if we can kind of do it like mentally. Okay.
Okay.
So we're gonna have 1 and 4.
Mhm.
So with this one, this is kind of where I'm getting confused.
Because it's not like the other one had like it was just,
Yeah, it was like more
yeah,
simple.
right.
So let me just double check my notes so I can see. Okay. So what? Why? I wrote that so weird. Oh my gosh, doesn't make any sense. Oh, now I get it. Okay. Oh. Sorry.
That's fine.
Okay, so my thinking is that this carbon right here, because this is the carbon we're looking at, right?
Right.
So we're going to look down the bond and we're going to have 2 C's.
Mm-hmm.
So my instinct is to go to the next highest one to try, because you're trying to break the tie, you know?
Right.
So I would say this one's 2 and then 3. So this is clockwise, but that's a lie. And there. Okay. Second one. Oops. All right. This is our 1. That's our 4. All right. So we're going to look down the bond. So this one seems easier because this is C whatever, and this has 3 H's. So you can just put that as 3. And this is 2, right?
Yeah, okay, I'm following.
Yeah, because that is this carbon right here.
Mm-hmm.
Or really, to be precise, that one. Okay. So 1, 2, 3, 4. That is S, and our hydrogen is on a wedge. We're going back to R. Is that right?
Okay. Mm-hmm.
1, 2. I have it different in my notes.
I'm thinking because, okay.
I think I'm mixing something up, to be honest. Let me just double check this one. Okay, no, oh, that makes sense because this is supposed to be R and it's S.
Okay.
There we go. That's why. See, look, the purple are these right here.
Right.
Yeah, okay. So we have 1, oops. One, 2, 3, 4, 5 carbons. So this is carbon 2, this is carbon 3. So we're going to have pentane, 2, 3, 2, 3 di bromo.
Would you? Yeah. Okay. 2 bromos. One's on 2. One's on 3. Got it.
Yeah, I put
right.
the numbering of the carbons in green. So this one, 2 is R, so 2R, 3S. Is that right?
Okay.
Right. Cool. So let me pull up that thing real quick for you so I can let you go. It might take me forever to find it.
It'll be
But it seemed like it made, I mean, I think it makes sense if they put it on a website, but like, is this it? Is this it? Let me see. It's basically, basically it's called the hand rule. Oh, here it is. I found lit. Share screen. Okay. So this is telling you how to do the left right. Or use the hand rule.
Oh.
So orient the lowest priority group up. The lowest. Point your thumb in the direction of the lowest priority group. Okay, so it means point it up. If you need to use your right hand so that your fingers point in the direction of the group priorities in the order 1, 2, 3, then it's R, because R is your right hand. Okay, so this is what I'm trying to understand. If you need to use it to point in the direction of the group priorities, that's what I'm not understanding. Oh, so, okay, let's see. So in the direction of the group priorities, 1, 2, 3, and then you're rotating your thumb the same way.
Okay.
I think that's what it's saying.
So
So we'll try it
like
for this one. Yeah, like, so your hydrogen is up, and if you numbered your priority groups, then it's the right hand. So let's try it on this one. So let's see if we agree with all the numbering. H is 4. Oxygen beats carbon. That's 1. Oxygen beats hydrogen. Yeah. Okay, so we're going to have 1, 2, 3, 4. So with this one, let's try to use the right hand for it. So if you put the hydrogen up, if you turn it that way, you're going 1, 3, 2. So if you use your left hand,
okay.
you're going to do 1, 2, 3. You see that?
1, 3.
You see how this one?
Yeah.
And it's
1,
so weird.
3.
I was, yeah,
1,
because
3,
you,
2.
which is no, that's a bad because you,
Okay.
it's not in order. It's not in the priority group order.
Okay.
Interesting.
I'm gonna look back at this video and try and understand it, but right now it's kind of fresh.
No, yeah, no, I have no idea how to use it. I tried doing it last night.
I
I
was
don't
like 1,
understand
3,
it.
2.
Yeah, yeah. Don't get that in your head. That's wrong.
Oh
That's not
God.
our priority. Yeah, I can send you that. If you want to put in the chat your number, and I can just text it to you real quick.
Yeah, let me get quick. I'll send it.
So the worksheet, I feel good about, ish. Just the other stuff I was looking at, I thought I could apply that stuff, and it was just like not having it at all.
Right.
So if you want to clip that out of the video when you post it, please feel free.
I don't know. I just put it up there, but I'll see if I can like cut it because the first like 20 minutes we were like, what?
Yeah, what? And, yeah, that's why I was like, you can definitely. This is a lot more. Oh, I don't want to yell at you. I have caps lock on. Okay. All right. There you go. I sent it to you. So, yeah. All right. Well, you enjoy the rest of your day.
All right. Thank you so much.
Yeah. Do you want to do another one later this week?
Yeah, for chapter 6 or
Yeah,
for
maybe
chapter 5.
might want to double check chapter 5, just maybe they just some other projections and stuff just to look at them, you know. And then yeah, definitely chapter 6 because I'm sure it's going to be a doozy. And
Right.
we can figure it out in the chat whenever.
Yep.
All right.
Okay.
Bye. Nice to meet
Bye.
you.
You too.
Bye.